Hi, I'm Mike Schwartz, the founder of Glue, and today I'd like to share with you a presentation I did at the European Identity Conference last week, Thursday, May 8th, on token-based access control, or TBAC. And you might be wondering, why do we need another access control mechanism? Why isn't RBAC or ABAC or one of the other BACs enough? Why do we need yet another one? Why would we want to confuse customers? And well, let's take a look at where we are right now. So the current situation, which is really a legacy of the 90s, I'm just going to point at three reasons why I think that we're in bad shape. The first, I would say, is that MFA is a mess. And what I mean by that is that the holy grail of MFA is continuous authentication, or the ability to step up authentication when the risk of the transaction warrants it. But we're still struggling to actually do this in today's applications. Second, I would say that one of the existential challenges of federation and single sign-on is single sign-out. And 20 years later, this is still a problem. We're still struggling to log out of applications, or to enable, let's say, some type of logical log out of all the federated applications which we're logged into. And finally, I'd say that centralized policy management is actually more the exception than the rule, and that we've been talking about centralizing policy management for a long time, but we have yet to achieve it. One piece of good news from recent times is that a standard has emerged for tokens. JWTs, or JSON Web Tokens, have emerged as almost a ubiquitous secure token format. And that's good news, because we're going to need that to solve our access control challenges. Now, in addition to these existing challenges, we have new challenges. And first new challenge is that we're seeing that there's more software than people. If you think about your mobile phone, you have all those apps on your phone. Each one of those apps has its own identity. So you very quickly can realize that there's more software than actual humans. And beyond that, there are software agents running in the cloud. So you've probably heard the expression, software is eating the world. And we see this defined in new types of ways, like non-human identity, or machine-to-machine, or workload identity. And this is a trend that's probably just going to continue and get even more challenging. One of the holy grails that we're looking at of authorization is AI agent delegation. How do I get an agent to act on my behalf and interact with other pieces of software? You can quickly imagine, if I want a software agent to book an airline ticket for me, how challenging that's going to make our authorization and access management security topology. While the good news is that we have JWT tokens, the bad news is that we have a lot of different JWT token types. We have access tokens, ID tokens, we have software statement assertions, we have just a number of different tokens out there of attestations and assertions, FIDO passkey attestations, and software integrity assertions. So there's just more and more types of JWTs out there, and it's really hard for developers to understand what the contents of all these tokens are, and how to validate them, and how to use them. And I joke that to actually understand all this, developers need a PhD in tokens, and that's not helping us solve our authorization challenges. In addition to these new types of tokens, we have new types of credentials for humans, especially credentials coming out of a wallet or being presented from a wallet. And also making access management difficult is that in the old days, we had a known perimeter, our organization, our enterprise. But today with federation, access control has to cross organizational boundaries, and that's creating new challenges for us. And even within our own enterprise, let's say, we have this idea of zero trust, where each component can't trust the other components. So if you're an API gateway and you're making a request to a backend, that backend can't really trust maybe the any information that you send it. It needs to validate information by itself. And this is also creating challenges for access management. And finally, we have now disconnected use cases. So we have, believe it or not, you could be somewhere and there'd be no internet. Maybe you're hiking in the wild, or maybe you're just in some area where there's just no internet, and you still need the application and software to abide by policies that have been laid out by the enterprise or by who's ever governing your software. So why do we have to do something now? That's always a question. We could do nothing. Nothing's always an option. But I would argue that nothing is not a great option these days. We've tried retrofitting access control to our current legacy access control, let's say RBAC or ABAC. And I can say with some confidence that this is failing. And you don't have to look too far. For example, I mentioned the lack of the ability to do stepped-up authentication, the lack of the ability to log out. Well, logout's probably the most important authorization decision. Should I display my application and allow people to log in or to enter input? That's an access control decision. When do I need to authenticate somebody? That's a really important access control decision. This transaction looks risky. I need to step up that authentication level to make sure it's really that person. So our existing mechanisms and access control systems, they're just not cutting it. There's a move in cloud native infrastructure to declarative configuration, and I think this applies to access control also. We want to move our security to declarative policies. And that means that we can manage our policies like code, review them like code, QA them like code, and have them move through the life cycle in a way that's let's say not in code, but is more in configuration. And finally, we just need to detect more threats. The threat surface area has gotten huge, and a lot of this threat happens after authentication. So you authenticate sometimes infrequently in certain applications, like when's the last time you logged into Uber? Airline applications might be hesitant to relog you in because maybe you'll miss your flight. So a lot of the authentication and access control challenges we're facing, they happen after authentication, and we just need more data in order to detect these new threats. And so my theory is that these older access control models aren't working, and we need a new mental model for authorization. And fundamentally, I would say the challenge is that we made the wrong decision about access control, probably like 40 years ago. I have a colleague, Alan Karp, an Internet Identity Workshop regular, and at the last IIW, we were talking, and he said to me, in the 70s, we had two doors to go through. One was the identity access control door, and one was the capability access control door. And we went through the wrong door. We went through the identity door. And that probably made sense in the 70s. But I would like to propose that in going through the wrong door, we've had to do all sorts of contortions and backflips in order to make the security model work. It's sort of like when I was in grade school. I saw this great animation, which you're looking at right now, of how the movement of the planets could be explained with Earth at the middle. And that was called the geocentric model. And however, when you looked at this other heliocentric model, it's just so much simpler. And I think we're in a situation right now where the capabilities-based model presents a much simpler solution, and we need to stop trying to make identity-centric access control work. So what does that mean, capabilities-based access control? Well, it means you start by defining the capabilities in your application. Um, and then you define the policies that authorize that capability. And then you send those policies to the CISO or through your code review policy, because obviously policies need to be reviewed. Right now, what happens is that we send applications the roles or identity information about a person, and then the application developers have to do some brittle mapping to capabilities. That mapping might involve a lot of if-then statements, or it might involve some type of table where you do that mapping, but it leads to a very brittle security model that's hard to update. So I've been advocating for token-based access control, which I think represents a capabilities-based model for authorization. And well, before I get started, it's probably worth having a conversation about what tokens are. Tokens are, as the slide says, self-contained cryptographically signed bundles of claims. So I'm using tokens pretty widely here to include any type of way that we could sign claims. And as I mentioned, we have a lot of identity-based claims, OAuth tokens, OpenID tokens, verifiable credentials, i.e. coming out of a wallet, for example. But we also have non-identity-based tokens. For example, an attestation from a passkey authenticator about, or an attestation from, let's say, the FIDO metadata provider about what type of authenticator this is. Is this a shared, an authenticator with a shared private key, or a device-bound key, for example? We have platform authenticators, for example, from Apple or Google, that might tell us important information about the app. For example, has the checksum for the app changed from the time it was on the Play Store to the time it was installed on the app? If somebody hacked the app, we probably don't want to trust it. And we also have enterprise tokens, which could mean, which could represent, all sorts of things. So that's what we mean when we're talking about tokens. We mean all of these tokens. For example, let me add one more. In the non-identity-based tokens, we have new tokens. There's a new OAuth effort called WIMSI, the Workload Identity Management group, and they're defining a whole list of new tokens about workloads, or which is software or clients, let's say, or non-human entities, non-human identities. So there's a lot of tokens. Now, I don't mean, well, let me just, sorry, I missed my last point here. Tokens are evidence. So in today's world, with all the misinformation and disinformation out there, it's hard to find truth. And tokens represent truth as attested by the issuer. So you can think of tokens as evidence that we can use in our policies. So now, what do I not mean by tokens? So, okay. Okay, sorry, I missed my slides are out of order here. I don't mean hardware authenticators, like YubiKeys. Those are called tokens, but I really don't mean those types of tokens. We're not talking about crypto tokens like NFTs. We're not talking about subway tokens, if people even use those anymore. We're not talking about reference tokens. In OAuth, you might say, oh, there's a non-guessable string that people call that a token. By the way, not to be confused with a bearer token, which could be either a reference token or a value token. But remember, I define tokens as self-contained pieces of data. Um, and so a reference token, which is just an ID, doesn't actually have the data or the signature. So I don't mean those kind of tokens, although people call them tokens, and that's fine. Let's talk about token formats. I mentioned that JWT is really an important innovation. There are other kinds of tokens like X509. Certificates are also a cryptographically verifiable way to send information. We see them, for example, used in smart cards and other applications. But JWTs just end up being more extensible. So if you want to add claims, it's easier to add claims into a JWT than an X509 certificate. So there's nothing wrong with X509 certificates. I think that we're just seeing that JWTs are more useful. As a joke, I wrote Kerberos tickets or DSML. So what my main point is here is that we're mostly talking about JWT tokens. And okay, so what is token-based access control? We've talked about what tokens are and what they're not. And so simply put, token-based access control is a mechanism where we use one or more tokens, read JWTs, to authorize capabilities. Think about it like a bundle of tokens, like a whole bunch of tokens put together. We're not talking about one Uber token. That would never work. Just for example, let's talk about a new OAuth standard called transaction tokens. Transactions might be very granular. We might have a number of transactions that build into one sort of related set of information. Like I delegated authority to this person, and then I delegated this authority to this organization. And so when I see a piece of software that provides those two tokens, then I can make access control rules about it. Maybe I can't authorize something without the delegation of the person. So the net of this story is token-based access control means that we're sending a bundle of tokens or a bundle of evidence. And based on that bundle of evidence, we are making access control decisions. So what does a TBAC request look like versus an ABAC request? So in these requests look pretty similar. Traditionally in access control, we talk about PARC, principal, action, resource, context. So in an RBAC or ABAC request, the principal is normally a person or a workload. And the main difference between RBAC or ABAC and TBAC is that in TBAC, instead of the principal being a person or workload, the principal is a bundle of tokens. So note, this is identity-based. RBAC and ABAC is identity-based. The principal is always a person. And I would say the TBAC is not necessarily identity-based. The tokens could be about an identity, but they could also be about workloads or software or other entities. The action and the resource collectively are what we're calling the capability. And so this has led us to new requirements for our policy decision point. In the old days, our policy decision point would just need to make decisions. We send the PARC request, we get back the decision. But now in token-based access control, I would argue that our PDP, or policy decision point, needs to both validate the tokens, map the tokens, because if we have multiple tokens, potentially we have multiple subjects, and then make decisions. And previously, mapping the tokens and validating the tokens was the responsibility of the developer. But this, as I mentioned, with all of the different token types, it's getting really hard. And understanding what's in those tokens is required in order to map those tokens. For example, if I have an ID token and that has a subject and an audience, the subject implies a person, the audience implies a piece of software or a workload. So I have two entities there. I might have policies where a person might be allowed to do something, but only from a trusted piece of software. Like maybe I can call an API, but only from my trusted bank app, not from a third-party fintech app. So that is token-based access control in a nutshell. And before I end, I want to just address some questions that I get pretty much every time, so probably worth just heading them off. Aren't reference tokens more secure? Is putting that payload in the token, is that really secure? And according to Auth0, you're not supposed to put any sensitive data in the payload. Actually, this is just according to one random article at Auth0. And I would say, well, actually, um, um, this is probably not true, because we the payload always contains sensitive data. What ID token and what access token doesn't contain sensitive data. So if you get back the JSON, it's still going to contain that sensitive data. Um, but importantly, when you send a reference token, you can't send it downstream. And if you do send it downstream, like let's say you get that reference token as an application, you introspect it to get the JSON payload, you send that payload downstream, you've now lost the provenance because that downstream application is trusting you to have done introspection and send the right results. Well, in zero trust, it says we shouldn't do that. So by sending the token and not just the JSON payload, we're able to maintain the provenance downstream in the backend and in the database. Finally, using the value tokens versus the reference tokens enables us to have autonomy of the microservice. We want to make sure that the microservice doesn't make connections to backend services, in which case it becomes a lot more fragile. And you want these microservices to be very reliable. So we don't want to introspect tokens because that would add a round trip in from the microservice to resolve them, and that breaks our microservice isolation. This is the main question I get pretty much every time. There's no way I could possibly make important policies unless the policy decision point can itself gather data. I have two answers for this. My first answer is that the right place to do this is probably, if you need to enrich the data, the best place to do this is probably in your IDP. And that way you can enrich the tokens, sign the tokens, and make your policy based on that. Now, a lot of people will say to me, oh, but we're using Azure AD and I can't change those tokens. Those tokens are static. And my answer to them is, well, enterprises are going to have to get better at enriching tokens. And whereas, Entra or Google is giving you an ID token, nothing says that you can't use that token, orchestrate it, and issue a new token with the enriched claims that you need. So I just think in general, enterprises are going to need to get better at enriching tokens. Second, applications could actually gather data themselves and put that in the context, which could be used for policy. So there is a way to get real-time dynamic data, but maybe it shouldn't be the PDP that's doing it. Maybe it should be the application itself if it needs that data. Token bloat. Oh my goodness, these tokens are going to get so big, things are going to break. So my first response to this is yes, be aware that if you're sending tokens in HTTP headers, you have to be aware that infrastructure like API gateways or other things that might be proxying this request might have limitations about size, and you have to make sure that that's going to work. That's sort of the table stakes of using tokens. Um, Now, sending tokens in HTTP headers, not the only way. You could send tokens in the payload. Tokens can be obtained through system APIs. We've seen recently a proposal to use server-sent events to send tokens. So there are other ways to send tokens. But yes, be aware of bloat. But there are ways to send tokens, even big tokens. Second, I would say don't forget about data minimization. We always want to send the least amount of data necessary to do the job. That's what I would consider to be just basic hygiene. What would a token-based access control topology look like? And I know this slide is small. Apologies about that. You can see it on Glue's website if you want more detail. But the idea here is that in a token-based access control topology, we have policy decision points everywhere. So the application has a policy decision point embedded in the mobile app. The IDP must have a policy decision point embedded in it. One of the most important decisions we need to make in the enterprise is how to populate those tokens, and that can be a result of policy evaluation. Should I issue this access token? Well, that might depend on the tokens. Second, we probably want to have a PDP in the API gateway. Should I even proxy this request? Maybe it needs certain access tokens to do this method on this endpoint. The backend obviously needs policies. And finally, the database itself needs policies. Maybe there are policies that the API gateway or the backend doesn't even know about. And so maybe there's top secret data in that database and we need to filter it out. So the database itself needs a PDP in order to enforce policies on what data it returns. This is what we call zero trust, policy evaluation everywhere. Why do we even need authorization in a consumer-facing mobile app? This I get all the time. I mean, yes, enterprise authorization can be trickier. You have more roles, you have more capabilities that you need to govern within your workforce than within the consumer. But there are still some really important consumer authorization policies we need. As I mentioned earlier, stepped-up authentication is one of the most important. Based upon this transaction, does the policy require greater authorization? Stepped-up authentication has always been an authorization policy. Even back in the SiteMinder days in the 90s, stepped-up authn was an authorization policy. Second, as I mentioned before, logout, or when to end the session. This is an authorization policy. It's ultimately up to the application to determine whether it should still be displaying content and whether it should still be accepting input. That is based on current information, like are the JWTs that it's using, have they been revoked? If they're revoked, maybe it's time to log out. So I don't think there's a solution for authorization or logout that doesn't involve better authorization. I'm sorry, I said authorization, but I meant session management. So there's no way to solve session management or logout without proper authorization. And finally, I should just mention, obviously, we have entitlements. What subscriptions do you have? What services are you getting? Consumers have entitlements too, and applications need to display content and call APIs based on the entitlements of consumers. So even though consumer auth is easier, it's still very important. So to conclude, what's the promise of token-based access control? Well, first of all, through token-based access control and capabilities-based access control, in general, we can model the world. We can't model the world if our model is mostly puts identities at the center. Second, we need to reduce the cognitive load on developers. We need to help developers so they don't need a PhD in tokens, so that we can help them with a mapping of what these tokens mean, so that we can basically say to developers, instead of having to implement tons of if-thens and other security mappings, brittle security mappings in their application, we can say, all you need to do is get your tokens and then say, present your tokens to the policy engine and say, for these tokens, should I be able to do this capability? And that's it. I have tokens, capabilities, yes or no. So we need to make security easier for developers so that they can do what they care about, which is build the best user experience for their developers. And finally, we need the promise of TBAC is to be able to detect more threats. We need better information coming from everywhere on the network in our zero trust, component topology. And in order to do that, we need a common approach for security across the enterprise. And token-based access control provides a way for applications in the edge of the network, like the mobile app, and at the other side of the edge, which is the database, to use the same approach. And no other mechanism, I would say, really provides an end-to-end solution for security. So with that, if you bore with me, thank you very much, and look forward to hearing your questions on LinkedIn. Thank you.